everyone. My name is Kerenza Harris. As we're just announcing, I work at Morphosis Architect, and today I want to have fun, and I'm just going to talk very focused on kind of some of our digital strategies that we use in the office, computational technology, and how we leverage that to really kind of maintain design integrity and architectural agency, really. Okay, so today, I just want to make sure it's fine. Okay, so I just want to give you like a little bit overview of where we are today, because we've changed quite a lot in the last few years. We still have our main office in Culver City and New York, and we have about 60 to 80 employees at one point or another. And for the last few years, we've had about 20 plus projects active at any one time in different phases of a design. So if you take a look at the kind of the map here, we're active in a lot of places in the world, and we do have satellite offices that support projects that occur in different locations, and they kind of come in and come out depending on the type of projects that we're working on. And if you take a look at the latest or the last few years of making of architecture in our office, you'll kind of maybe notice a few things that have evolved or shifted, I would say, a little bit. We're undertaking a wider range of scales, from regional design to city design, master planning. We do large architectural projects, and we also go all the way down to very small kind of unique conditions, interiors, hotel room design. So there's kind of a wide array of scales. And that also comes with a wider array of building typologies that we have to address and kind of learn or gain experience on as well. And we're moving back and forth between this macro and micro scales to kind of address all these variations. We also have building types that are quite different, that we're starting to explore a little bit more differentiation in that. And so that's part of also kind of broadening our approach and the type of work that we work on. So in order for all of this to happen in an orderly fashion, we have to really, and you know, I didn't mention the word international, but obviously you can see that some of these buildings are coming from everywhere in the world. And so we address kind of common denominators, which are usually centered around environmental challenges and performance requirement, depending on where we are, all contextually based on where we are working. But in this context, it's really asking us to kind of really focus our energy a little bit and kind of present a kind of solid infrastructure. And so what we've done is we're kind of creating you know, a kind of computational infrastructure that supports the design methodology. The methodology is started in the 70s when the firm started, and today it's evolved in this kind of hybrid version, in this kind of newer, more kind of contemporary version of that. It's heavily, let's just say, it's essentially kind of systematizing input and putting it into the architectural composition, right? So it's a kind of a system that takes all the factors that can influence a project, and it's putting them together, integrated in this kind of organizational framework. And it's scalable and it's flexible, so it really allows us to kind of work in different ways, right? Or different scales and everything else. Now, that design methodology needs to be kind of supported by an expansive digital infrastructure, and that infrastructure is kind of intrinsically connected with the work. So there's really no longer kind of separation of those different methods of making and thinking. And so we do a little bit what a lot of firms do. We have a centralized 3D digital model that's operating at the nexus of like a network. Things coming in, maybe visual simulation, methods of simulation, prototyping, documentation. We have a robot in the office as well, and physical modeling. So all these things are coming in and out of the. Try to see if I can get this bar to disappear. Okay, so what's really been like kind of developing also recently is that we're dealing with data and geometry. Really, is where the kind of the scalable power comes into play. We want to acquire it. We want to create the data. We want to also own it, right? And we want to translate it and interpret it between the different factors. And ultimately, we're integrating this data in the system that I just mentioned. And then we begin to kind of establish rules within that system in kind of operational rules that guide how the data is being integrated and how it interacts within multiple sets or other types of interaction. And so the choices that we make in the rules that we impose in the system will actually lead us to kind of the emergence of new geometrical conditions, right? Because now we started to kind of dictate or engage this data to behave in a certain way. So in this very basic example here, you can see that we have drivers, what we call in the office, which are lines, planes, and primitives that are kind of non-physical entity, but they are kind of guiding a certain kind of underlying organization. And then the variation of that formal resultant is an output of this interaction, and it's an evolutionary output. It's not a recreate, erase, redo. Now, just in our architectural design software, we have 4. And so part of the work that has been happening internally is that we're trying to merge these guys, like everybody else is, in a way that is seamless in real time or the appearance of real time. So we're dealing with kind of like a wide array of opportunities here. And so we operate, everything is kind of operated at different level depending on which project. And so in a very, very basic, right, very simple example, we reproduce processes from one software to the other. And sometimes we reproduce it in one software so that it's integrated into, let's just say, the design environment. But sometimes we go across software. So we're trying to kind of very like in the trench work, right? We're like a small office and we don't have like dedicated research or black box groups. But so we're kind of trying to really kind of facilitate that design process or methodology using these very kind of underground tools that connect the pieces together. This would be like a Rhino Inside version, but for a different software. So where we're rebuilding native geometry into a different software. And then the next one that I'm going to show you is going to be exactly kind of, again, the same type of operation. And this time, we are also creating a series of tools that allow us to control geometry or to optimize geometry. So this is this maybe simple curves history, but curves are difficult. 3-dimensional curves are harder. And so we're kind of devising like little strategies to kind of help with the workflow and create some kind of cohesion and not having to stop everywhere. Because we have some complex geometry, we're repeating some, it's not looking great here, but we're repeating some of the kind of geometry construction within one project or another for documentation, for example, in Revit. And then in this case here, we're defining all our details, in this particular case in Rhino, because it's easier to visualize and kind of make sure that we're capturing every condition in the building. And then these are automatically kind of updated in Revit and allows also that visualization to happen in Revit, right? So, because we felt we needed it, right? It's not nothing else, we're not trying to sell anything, we're just kind of really trying to kind of facilitate a certain kind of design process that in any way that we can do that. This is another one. We use a simulation. We were working in LA, we're designing it in LA, and the project was managed in France, and the installation was built in Milan for the design week. That was in 2019, and so we simulated the experience in real time. We choreographed the movement, the speed of rotation of the panel, the digital content, which is our work as well, sound, light, color, and overall experience going beyond just the generation of a space, but actually more an interactive space. We created an XR app, which allowed for a more interactive relationship between, obviously, the content and the visitors that came to the installation. And we created kind of a really highly controlled environment, but the people who are actually visiting are feeling that it's open and free and full of unpredictability, and that's the goal, right? We also, in the last few years, 4 years I would say, we continue to look to other industries such as gaming, virtual film production, storytelling, software and hardware manufacture, to remain engaged because all the latest development more than that, but in areas of XR and real-time technologies, for example, is going way faster than we can understand it, right, in a way. So we are now participating, we're kind of collaborating with some of these content creators to develop the content itself, but also to kind of stay in the world of all these developments to kind of make sure that we're not missing out. And if we see anything that we find interesting, we'll borrow it. But then also what was interesting is that they did not realize that architect understood space. So that was interesting. So we had a lot of good interaction. So what does this mean altogether? Because I never thought I would ever say the word data in my presentations, but it means that by controlling this flow of information and at the kind of object level, but also kind of applying an overarching organizational infrastructure over the project and using the digital framework to support that, then we're kind of allowed to gain more control over the geometry. So for this particular project, on the other side of this model, you saw those little white pillows. So this is a project where, in this instance, the initial design of the pillow, the geometry is meaningless, right? It's not about material, nothing. It's just a pure resultant of a series of light and shade studies, right? So the geometry doesn't have any meaning. It's just based on performance requirement, and we get this three-legged element. So as the parametric data is integrated in the system, that geometry then begins to evolve both in shape and meaning. Now it's starting to have more kind of information in it, and it's using it. It's just not, we're not just dumping something, information in the object, we're actually using it and leveraging that. And so the over time, we have materiality, it's FRP in this case. We have physical mock-up, structural integrity analysis, because we want the object to be self-structured, and fabrication comes into play as well. And so we're going beyond like a simple, as I said just a minute ago, like beyond simple data integration. We're kind of identifying and defining the operational set of rules that control how the geometry and the data are combined together. And so the panel is intelligent and gives us real-time feedback, right? So this small component interacts with the ones beside it, and then also as an assembly, they interact also with other parts of the building in this case, right? So it has like broader implication of what it actually is. But in the end, what we've done here is we're controlling this geometry at a high level, but it's actually giving us more freedom because every iteration of the panel performs at the same level. So we could have 1,000 options, and now really the end of the line, the choice is really an aesthetic choice of what do I like, what do I not like. It's no longer taking on all these other elements because we've achieved a component that has that intelligence built into it. And then here I'm going to show you a project that we just finished, just to kind of give more context to the conversation that we're having today. And I just wanted to show you this project, which is the Orange County Museum of Art in Costa Mesa, which is in California. It's a 53,000 square feet museum, and it's nested in kind of the cultural center of Costa Mesa, for those of you who are familiar with the area. And we use some of the advanced tools, digital tools, on the design of the terracotta facade. In the atrium, which is the highest or the highly kind of articulated and eccentric area, and then the front zone of the entrance is also a part of that. Again, in kind of really kind of opposite of how we deal with the rest of the building, which is most of the building, which is more composed, calmer, quieter to support obviously the artwork that's being presented there. The project started a while ago as a competition, and then we went through a series of iteration, and we started kind of earnestly in schematic design, I think around 2018, if I remember correctly. I don't know, I was blanking out earlier. And so one of the first things that we did immediately is that we separated our building in scopes, because we knew that the articulation of the facade was going to require an additional kind of, a set of like a level of detail, but also this advanced technology. And so internally, we kind of broke the building into pieces so that we would take a scope for exterior with these advanced tools, and the rest of the building, which was much more, repetitive, orthogonal, and kind of clean, would just kind of be, managed by the rest of the team. So the competition facade pattern was kind of originally conceived with these very hard horizontal dominant lines that are running across a primitive solid, which is our terms, which is like sloped surfaces, tilted cylinder. And throughout the design process, we looked at a variety of material, which I'm not going to explain today, but we ended up with a terracotta tile. So we met with the fabricators and we learned everything we could about the material. And again, that information kind of it's brought back into the office, and then we kind of integrate it into our system, right? What's interesting about this one is that the intelligent module of the tile begins to inform the design of the facade in very unexpected ways. Because we wanted to do a tile that's 12 inches high, varying length, but it has to remain a rectangular and it can only be curved in one direction, that immediately started to deviate from the horizontal, because anytime the architecture gets more and more eccentric, this pattern starts to veer off in different locations. So it retains a certain relationship to the surface or to the face of the building. And so the building is getting designed and moved, and so we're trying to create like a connected set of processes that allows us to kind of update everything at the same time. So in the digital model, we have primitive geometry that's being rationalized and cleaned. It's highly controlled globally, but also locally for each element. And then the primitive geometry exists both in folded in 3D space, but it also exists as an unfolded state simultaneously. And then the tiles exist both in a flat orthogonal pattern on the ground, right? But then they're also existing as a three-dimensional element, as a folded element back on the facade, right? And everybody's kind of knowing where they are, who they are, how they're kind of, what their kind of behavior is supposed to be in terms of adjacency or location around, in relation to the building. And then we also added this kind of optimization of the pattern that happens in this space, and then it goes back to the tiles at the beginning where they begin to kind of absorb that information and optimize themselves, I guess, in a way. So the tiles, they exist as work point, they exist as wires, they exist as surfaces, and they have to exist as solid, because we want our models to be very, very precise in a sense, right? We're not going too far, but we want to have enough information that we can intelligently develop these assemblies, because we're proposing a curvature, and we want to make sure that we know what we're talking about and that it's going to fit and that it's not going to look crazy. So we are really kind of diligent about, again, our relationship with the fabricator, but also the documentation, and then ultimately on site, how things are coming together, what issues are we meeting, and it's always going to be a little bit more complex than the basic, regular, everyday fabrication for them, but hopefully with our relationship, we've managed to build enough kind of rationality in our design to make sense. So they're also creating models, and the reason why we do that is because we want to make sure that they understand the condition and that we're fully aware of every moment in this building, what happens and when it happens. You can see here some of the construction images and how that gets cladded with the tile at the end. And so, so this is our atrium. The structure is kind of tying the two pieces of the building together, but we're hiding it inside the design of the bridges. So ultimately, we have a design methodology that kind of really allows for kind of a singular application, because every building is different, and every time we do a new building, we kind of approach it with fresh eyes, and we kind of develop it that way. But it's always existing in this larger organizational system. So we're able to kind of manage all these relationships globally. We're not reinventing the wheel every time, although we're allowing for that individual kind of expression on each building. And so that's basically it, yeah. Thank you very much.